Hi there. Hope you have a fantastic day today. This lesson, I will go through 2021 HSC paper with you. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question 36. So we need to find the minimum times to complete the project. And we know that time is in minutes. Okay, keep that in mind. So this, for example, activity A needs 5 minutes to complete. Activity B, we need 8 minutes to complete the task. Okay, keep that in mind. Now we need to find the minimum time to complete the project. So to work this out, we just need to work out the earliest starting time, and then we go backward, and then we find the latest starting time. Okay, so just remember that. So let me just start with activity A first. So we always start with 0. That's for A. So this 0 here. And then for B, this 0. Okay, keep that in mind. Then to start on activity C, so we need to add 5 to 0. That give me 5. So let me just write this first. So 5, because 0 plus this 5 here is 5. And then for F, to start activity F, we need to complete activity B first. So the earliest time you can start on activity F is 8 hours later once you complete activity B. So there you go. So now if you think about it, 8 plus 6 is 14. So to start activity H, we need to complete E and F first. So to complete activity F, we need 14 minutes later. But we need to work out the time that complete activity E. So to work it out, we just work out the time for starting activity D first. So to start on activity D, we need to complete activity C. So 7 plus 5 is 12. So there you go. Then we can start on activity E when activity D is complete. So 12 plus 2 give me 14. So now to complete activity E, 14 plus 3 is 17. So therefore 17 is the earliest time you can start on activity H and G. So let me just write it on here. So this is 17. So keep that in mind. And then for H is 17 as well, because we need to complete activity E and F. So the earliest time you can start activity H is 17 minutes, okay, later. So then we're going to start on activity I. So we go 6 plus 17 is 23. And then to start on activity J, so let me just draw this. So we go 17 plus 5 is 22. And then to start on activity K, so we need to complete J and I. So to complete I, 23 plus 3 is 26. To complete activity J, 22 plus 8 is 30. So therefore 30 is the earliest starting time for K. Now to finish, so we need to complete activity K. So therefore 30 plus 10 will give me 40. So let me just draw the earliest and latest starting time for this, for K here. So that is 30 here to start activity K. So there you go. And then now to go backward, so we know that have to be 40 as well. Okay, now we're just going backward scanning. So 40 minus 10 is 30. Okay, so keep that in mind. So we're going backwards, so we take the smallest value. Forward scanning, we take the largest value. So keep that in mind. So now we have 30 here as well. Okay, 40 minus 10, so 30. So for I, so we're going 30 minus 3, give me 27. Then for J here, we just go 30 minus 8 is 22. And then we have 22 minus 5 So 17. And then we got 27 minus 6 for h, so that means 21. So 21 here. But then don't forget, we're gone backwards, so we pick the smallest value. So therefore, the earliest starting time is not 21, it's 17. So we pick that, okay? So the smallest value, gone backward. Then we gone back 17 minus 3 for E, so that give me 14. And then for F, 17 minus 6, 11. And 11 minus 8, so give me 3 here. Going to activity D, going backwards, so 14 minus 2 is 12. And 12 minus 7 will give me 5. And 5 minus 5 is 0. So that's about it. So now we can answer the questions. Find the minimum time to complete the project. So the minimum time to complete the project is 40, but it's units in minutes, so 40 minutes. So let me just write this down, 40. So there you go. Part B, state the critical path for the project. So the critical path for the project is where the floating time is 0. So we have the floating time 0 is here, 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 and here, here, and here, followed by this. So the path is here. So keep that in mind. This is the critical path. Okay, so keep that in mind. No floating time. So there is no floating time. In another word, the float time is 0. So that is I, C, D, I, C, D, and then E, G, J, E, G, J, and then K, of course. So there you go. Now, part C, a new task X is to be added to the project. The earliest starting time for X is 17 minutes. So 17 minutes, so that means have to be after the activity E and F, because the earliest starting time is 17 minutes. So therefore, we just start X here. Okay, somewhere here. So I can just draw all the way here. So that is X. And then the latest starting time is 18 minutes. So let me just draw on here. Okay, so for X, so 17, and the latest starting time is 18 minutes. So 18 here. And X has a completion time of 12 minutes. 12 minutes. So let me just draw an arrow here. So there you go. That is activity X. Yep, that's it. Question 37. So we need to find the side angles of A, B, C. So this angle here. Let's make this angle theta. And then have to be obtuse. So when we work out the angle theta, it's going to give us acute. So we just need to use 180 minus the answer. So to work this out, so we know that we have two angles here. This is one angle. This is counts another angles. So we use size rule. So opposite of this and opposite of this. So the rule is we can write sine of A over small a is sine of angle B over the side length B. So theta is opposite is 25. So we can just write sine of theta over 25 is 28 degrees. So that means sine of 28 degrees over 16. So I times 25 on both sides. So if I times 25, I times 25. So that cancels this out. So sine theta equal, so I just put on a calculator. So I just go sine of 28 over 16, then we just times 25. So there you go, 0.733 and so on, 0.733, and then therefore theta is inverse 0.733. So that will give me, so just go shift psi answer. So there you go, correct to nearest to degree. So 47 degrees. But then angle ABC is the obtuse angle. So we just go 180 degrees minus 47 degrees. So 180 minus 40 is 140 and minus 7. So that should give me 133 degrees. Otherwise, you can just use your calculator. So therefore, angle ABC is 133 degrees. So there you go. Question 38. So before we do anything, we need to look at the table and we need to understand what they are first, okay? So for example here, okay, for probability of 0 to z, okay, so from 0 onward, if you like, from the mean, if you wish. So let's say, for example, if I want to find the probability of z that is greater than 0 and less than, let's say, 0.4. So that will give us this value here, because the table gives the probability that is random variable lies between 0 to z. So keep that in mind. So if it probability from 0 to 0.4, that will give us 0.1554. Okay, that's how you read the table. So please keep that in mind. Now the question is this. Part A, using the table, show that the probability that a value from a random variable that is normally distributed with a mean 0 and standard deviations 1 is greater than 0.3 is this. So in another word, we need to work out the probability that is greater than 0.3. So the probability of z greater than 0.3. Now we know that the probability of z, let me write here, okay? So probability of z greater than 0 but less than 0.3 is this number here, 0.1179. Okay, keep that in mind. So in another word, we know that this part here, of course, is 0.5. So to work out that the probability greater than 0.3, so we just need to write down that becomes 0.5 minus the probability of z is between 0 and 0.3. Okay, keep that in mind, okay? Because we need to work out the probability that is greater than 0.3. So let's say this is 0.3, okay? So let's say that 0.3 and we want to find this probability. So in another word, 0.5 is the whole lot and we minus this probability out. So that's what that meant, okay? So now that becomes 0.5 minus, so between 0 and 0.3 is this. So that is 0.1179 equal, so 0.5 minus 0.1179. So there you go, 0.3821. So 0.3821. So there you go. Now, part B. A bird weights are normally distributed with a mean of 3,300 grams. So that is the mean. So let me just make note on this. That is X bar. Actually, let me just write this down. X bar is the mean, 3,300 grams. Okay. And a standard deviations of this. So that means SD is 570 grams. By first calculating a z-score, find how many babies out of 1,000 born are expected to be a birth weight greater than 3,471 grams. Okay, so we need to work out the probability of x greater than 3,471. Okay, keep that in mind. So let me just convert that to z-score first. So z is equal to x minus the mean. X is 3,471 minus the mean, that is 3,300, over the standard deviations, that is 570. So that will give me, so just go fractions, 3,471 minus 3,300, and then divide by 570. So that is 0.3. But then we need to find the probability greater than that. Okay, so we need to find the probability of z greater than 0.3, and it's already found out from part A. So that is this. So let me just write this down. So that is 0.3821. Then we need to work out how many babies are expected to weight more than 3,471 grams. So that means 1,000, we just time by the probability. So 3821. So that will give us, move 1, 2, 3, cancel this. Otherwise, you can just put on a calculator. So 382.1 babies. So there you go. And thank you so much for watching. Bye.